Good evening, all. So, the today's topic of discussion is loss of motion. I'm Sreehari C. I'm currently at third year MBBS in AIIMS Nagpur. Okay. So, we already discussed so many topics in this crash course. So, today is actually somewhat a little bit a little bit tough topic, loss of motion. Okay, we will discuss loss of motion in two session, part 1 and part 2. Today's session part 1 is comparatively easy. It is mostly the Newton's law, one, first, second, third laws, and inertia, momentum, impulse, and all. So today's session is comparatively easy, and the second session part 2 will we deal more with friction and all. So it will be comparatively tough. Okay, so let's see what we are discussing today. Okay. So today's topic is laws of motion, part 1. Part 1. Okay. See. So let's begin. Okay. So we will cover today's session in these much topics. First we will see what is inertia. Then we will see what is Newton's first law. Then we will see momentum, Newton's second law, impulse, Newton's third law of motion, law of conservation of momentum. Okay. So let's see what is inertia. Inertia means it is an inherent property of all the bodies by virtue of which they cannot change their state of rest or uniform motion along a straight line by their own is called inertia. Which means a physical body, a body cannot change its state, whether it is rest or uniform motion, whether it is rest or uniform motion by itself. Like when a body is moving in a straight line uniform motion or it is in rest, it cannot change its state by its own. It cannot change its state by their own. That property of the body is called inertia. That property of the body is called that body. That of the body is called inertia. Like a body cannot change its state of rest or uniform motion. Okay, that is called inertia. Okay, inertia is a property of any body having mass. Any bodies having mass is called inertia. Inertia is a property of body, and it depends only on mass. Okay, and it depends only on mass. Inertia depends only on mass. Inertia depends only on mass. Inertia depends only on mass. Okay, fine. Suppose it has no units. Suppose two bodies equal mass. One is in motion and another is in rest. Okay, they have same inertia because inertia depends only on mass and it is independent of velocity. So when one body is in motion and another body is in rest, they possess same inertia because inertia is independent of velocity and depends only on mass. Okay. Okay. I hope everyone knows this much topic. Okay, fine. So let's see what is Newton's first law. So let's see what is Newton's first law. Okay. Newton's first law. As per Newton's first law, a body continues to be in state of rest or uniform motion in a straight line unless it is acted upon by some external force. Okay. Let's see what actually Newton's first law is meaning. A body will continue to be in its state, in its state, whether it is uniform motion or rest, unless it is acted by an external force to change its state. A body should a body will continue in its state of rest or uniform motion unless acted by an external force, unless acted upon by an external force. A body, that means a body will not change its state. That means because of inertia, a body will not change its state or rest, or uniform motion. So to change its state of rest or uniform motion, we need to apply an external force. Okay, I hope everyone understands this much. Okay, so there are two inertia of rest and inertia of motion. Inertia of rest means it is inability of a body to change its state of rest. That is inertia of rest. So inertia of rest, inertia of motion, and inertia of direction is also there. Okay. Inertia of motion means okay, let's see an example for inertia of rest. Okay, inertia of rest. Suppose a bus, a bus is like a person is sitting in a bus, and bus moves suddenly. A bus moves suddenly, so the person in the bus moves backward. Person in the bus moves backward. So it is because of inertia of rest. So when we see an example for inertia of motion, like a person standing in a bus or a person sitting in a bus, when the bus applies brake, suddenly the person will move forward. That is called inertia of motion. Okay, and there is also called inertia of direction, like a inability of a body to change its direction by itself. So three inertia. Okay, so I hope everyone understand this much topics. So now let's see what is momentum. Before that, we should understand what is a force. Force is an external effect in the form of a pull or push. It's an external effect. It's an external effect in the form of a pull or push. We can experience force by a pull or push. Okay, fine. So let's see momentum. And here we are dealing with linear momentum. Okay, here we are dealing with linear momentum. Okay, fine. Linear momentum means it is the linear momentum of a body, means it is a quantity of motion contained in the body. It is the quantity of motion contained in the body. Okay, it's one definition. Otherwise, we can say it is measured in the form of in terms of force required to stop the body. Okay, in unit time. Force required to stop the body, force required to stop the body in unit time. Okay, fine. P, we can say P is equal to mv. P is a vector quantity. Direction is in the direction of velocity. In the direction of velocity, or in the direction of force, whatever we can say. Okay, P is a vector quantity. P vector is equal to m into v vector. Okay, fine. Okay, and the unit is mlt raised to dimension is mLT raised to -1 and unit is kilogram meter per second. Kilogram meter per second. Okay, fine. This much things. Now Newton's second law. It is important. It is important. Newton's second law is important. As per Newton's second law, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body. That is rate of change of momentum, dP by dt, is directly proportional to the rate of change of linear momentum is directly proportional to the external force acting on it. dP by dt proportional to F, or external force is proportional to rate of change of linear momentum, whatever. Okay. So F is equal to K dP by dt. Okay. As per SI unit or CG system, whatever system, K is equal to 1. So F is equal to dP by dt. And so we can write F is equal to, and we know dP by dt, that is F d by dt of mv. So m dV by dt. Okay. So it is equal to ma. F vector is equal to m into a vector. In some case, there can be change in mass also. Some cases. So that time we will write that means usually m is a constant. Sometimes m won't be a constant if m is not a constant. If m not equal to constant. So we should write F is equal to m dV by dt plus v dm by dt. See, simple. So okay, fine. So our formula is F is equal to ma. If that is our formula, F is equal to ma. I hope I know everyone know this equation very well. So like I want you all to know what is F is equal to ma is based on Newton's second law. F is equal to ma is based on Newton's second law. F is equal to ma, and we got this equation based on Newton's second law. Okay, it can be asked as a theoretical question. Impulse means like when a moving body hit on a surface, it will create an impact. That impact is called impulse. That impact is called impulse. Okay. Okay, and the unit impulse and the moment is same, and impulse is equal to same, like impulse is equal to mv actually, same as that of momentum. Okay, fine. So now let's see Newton's third law. Okay, Newton's third law. Okay. So we have seen first law, second law. Okay. Now we can see what is Newton's third law. So as per Newton's third law, to every action, there is always equal and opposite. That is, equal means equal in magnitude and opposite means in direction. Okay. To every action, there is equal in magnitude. Equal and opposite react. Opposite means direction. Okay. I already while I was teaching gravitation, I already taught you, like, if two masses m1 and m2, the force on m1 because of m2 is equal to g m1 m2 divided by r square, and the force on m2 on m because of m1 is also g m1 m2 divided by r square. But the direction is opposite. Suppose F is the force, F is the magnitude of the force with which M1 attracted M2, it will be like this. And the force on M2 because of M1 will be this. Both are equal in magnitude and opposite direction. Both are equal in magnitude and opposite in direction. Okay, fine. So now let's see. Impulse we see. Impulse already we saw. Impulse like impulse means it's a large force acting on a short interval of time. Okay, I'll give a definition now. Large force acting for a short interval of time. Short interval of time. Okay. Like dimension is same as that of dimension is same as that of dimension is same as that of moment MLT raised to -1, MLT raised to -1. Unit is same. Impulse is direction of impulse is in the direction of force. Okay, direction of impulse is in the direction of force. Direction of impulse is in the direction of force. Okay. Fine. And also we will say direction, like impulse is change in momentum. We will say impulse is equal to impulse there's a relation between impulse and momentum. Okay, impulse is equal to change in momentum. Impulse is equal to change in momentum. Impulse is equal. Once more. Impulse means large force acting for a short interval of time. Okay, short interval of time. I is equal to F dt. We know that thing. F dt. Fine. I is equal to F dt. Okay, fine. And impulse is equal to change in momentum. Impulse is equal to change in momentum. Direction of impulse is in the direction of force. Direction is in the direction of force. Fine. Newton's third law is over. Now, law of conservation of linear momentum. As per law of conservation of linear momentum, I already told you F is equal to dp divided by dt. Okay. F is equal to dp by dt. In the absence of an external force, if there is no external force, in the absence of an external force, linear momentum remains constant. Fine. And I want you to all to know the application of law of conservation of linear momentum. There is actually mainly two. There is mainly two application of law of conservation of linear momentum. One is recoil of gun, and another is rocket propulsion. Okay, one is recoil of gun, another is rocket propulsion. Okay, fine. So, like so many applications there, we'll discuss mainly two applications. Okay, I will say some example. For example, when a man jumps out of a boat on the shore, the boat is pushed slightly away from the shore. Another thing is like okay, like see, mainly we have two examples. We discuss two examples now. That is recoil of gun and uh, rocket propulsion. Okay, see, let's first see recoil of gun. Okay, recoil of gun. Recoil of gun. You know, in a gun. Okay, see, suppose it is a gun. Okay, it is a gun. Okay, it's a gun. It is having a mass capital M. It is having a mass capital M. Okay, and bullet is there. And if it is pressed, the piston, like and is pressed, the bullet will move with the velocity v. Suppose the mass of bullet is smaller, and the bullet I am saying v velocity, and gun is moving with the velocity vg. Okay, so when you fire a bullet, we used to see when while firing, the gun used to move backward. The gun used to move backward while bullet is fired. Okay, so what is happening actually, as per the law of conservation of linear momentum, there is as per law of conservation of linear momentum, when there is no external force, linear momentum remains constant. Okay, we know that thing. Here there is no external force. Everything is done by within the there is no external force. Everything is uh, done in the gun only. So while pressing, while the bullet is moving forward with the velocity vb of mass m, and the gun of mass capital M will move with the velocity vg. Okay, since in the beginning, what is the total momentum? Total momentum zero. When because gun is at rest, there is no moment. Okay, fine. So as per law of conservation of linear momentum, after firing also the total linear momentum should be zero. So zero. What is the linear momentum after firing? We know one is mvb, another is mvg. That is the two linear momentum, two momentums. So the sum of these two momentum should be cancel each other. That means these two momentums cancel each other. So mvb is equal to mvg. So recoil velocity of gun we can find with this, that is minus mvb divided by capital M. What means this negative means opposing direction. Opposing direction. Fine. Okay, fine. Okay. Another one is actually uh, another one is actually our rocket propulsion. Second one is rocket propulsion. Like I already told you one case, that is F is equal to d by dt of mv. Usually there is no change in mass of, usually there is no change in mass. M used to be constant. But in case of rocket propulsion, there is a change of mass, because in rocket we see there is a loss of mass is happening. It is a case of change in mass. Here the F is equal to m dv by dt plus v dm by dt. Okay, fine. This is the equation should be applied. Okay, fine. I'll show you one question, then you will understand clearly. Okay. Okay. Okay, we'll discuss the question later and at the end. So we should understand this much topics. Okay, fine. Now one more thing we have, that is concurrent forces. Okay, concurrent forces. Okay, concurrent forces. After the concurrent forces, we will start doing questions. Okay. See, let's see the equilibrium of concurrent forces. Equilibrium of concurrent forces. Equilibrium of concurrent forces. Like if all the forces working on a body are acting on the same point, then they are said to be concurrent. Okay. Like if all forces acting on a body are acting on a same point, like if a body is acted by so many forces. Okay. If all the forces that acting on a body are acting on the same point, then they are said to be concurrent. Okay. So I would totally like that. Concurrent forces means when all the forces that acting on the body, when all the forces that acting on the body is acting on a single point, is acting on the same point. Okay. Acting on the same point, then they are said to be concurrent forces. When we can say body is equilibrium due to concurrent forces, a body is said to be equilibrium under the action of concurrent forces. When we can say, like if the net force is zero, like if the body is not able to change its state or uniform motion with the action of concurrent forces, it is said to be equilibrium with the action of concurrent forces. That means the net force is acting on the body is zero. That means if there is F1 is the force acting on here, F2, F3, F4, that means net force is zero, F net is zero. So vector F1, vector F1, vector F2, vector F3, vector F4 cancel each other. Okay, simple. That this much only. Now I need some more things to do the questions of this topic. Okay, I'll discuss some cases. Okay, then you will understand. Okay, fine. We need to understand the concepts. Okay, now this. Okay, then we will clearly know how to deal the questions. Newton's third law, second law, first law, everything should be, the concept should be very much clear, so we can deal the questions very easily. Okay, fine. Suppose a body is in a lift. Okay, if the lift is at rest, the mass of the body should be capital M. Okay, if the lift is at rest, what is the mass of the body? It is capital M itself. Okay. So what is the weight? Is equal to mg. If the lift is moving with a uniform velocity, if the lift is moving with a uniform velocity, what is the mass? What is the weight of the body? It is again mg. Suppose if the lift is moving upward with an acceleration of a, what is the apparent weight of the body? Then we have an equation F is equal to, that is weight is equal to m into g plus a, because m lift is moving with the acceleration a. So there, as per Newton's third law, there will be opposite, equal and opposite action will be there. So here we have already the body is acted by its weight mg downwards. Okay, and that mg will be given upward. Okay, fine. And lift is moving with an acceleration a upward. So there will be downward acceleration to this body, there will be downward acceleration of a, that is ma. So net mg plus a. Okay, this is due to application of Newton's third law. Okay, fine. No need to know all these things. Like just we know all these things, like when a body is moving, when the lift is moving upward with an acceleration a, apparent weight is equal to a acceleration above m into g plus a, and is going down m into g minus a. Free fall 0, m into g minus g 0. Okay, fine. This much things we should know. Now some more things we should know. That is some free body diagram. Okay, some free body diagram. If a body is pushed with a velocity, force with an f, so acceleration is equal to f by m. I hope everyone know this thing. F is equal to, the force is actually f. Okay, so acceleration is equal to f by m. Okay, suppose two masses m1 m2 is there and it is pushed. Same acceleration should be, total force is f divided by m1 plus m2. Okay, so see, here the body will have a force of m1a. Okay, m1, this body have a force of m1a, and this body should have a force of m1a plus m2a. I'll explain you why. Due to this force is acting on here, so there will be a repulsive force. So as per Newton's third law, there will be equal and opposite force. So m1a is acting on, like when the body is giving m1a, there will be same m1a from here also. And this body is moving with it already have an m2a, so total m1 plus m2a. Okay, I'll explain one more time. F m1 m2, it is moving with m1a, it is having a force of force on m2 is m1 plus m2a. Now in case of pushing, okay, m1, okay, I will show you one example then. In a table in a table, there is a body. Okay. And okay, it's a rolly, or a pulley. Okay, whatever. It is having a force of capital M. Okay, this is M1, this is M2. Here the net force is due to, if this body, if it is moving, the body have there should be an acceleration. Okay, so here it doesn't have any force. It doesn't produce any force. But and here the force is only due to M2G. Okay. So F is equal to M2G. Okay. So acceleration of the body is total acceleration is equal to M2G divided by M1 plus M2. Okay. Fine. So the acceleration of M1 will be acceleration. So force on M1 will be M1A. Okay, fine. This much things we should know. Okay, I hope everyone understand this much things. Now we can see some questions. Okay, then you will understand it concepts more nicely. Okay. First, a person is sitting in an open car moving at a constant velocity, throws a ball vertically up into air. The ball falls. A person is sitting in the car. Okay. Throws a ball up. Okay. Throws a ball up. The ball falls. See, in projectile motion, we already see this thing like in a projectile motion. Okay. Here, while ball is thrown vertically, when the ball is thrown vertically, even if the ball is thrown vertically, while the ball is moving in the car, the ball have the same velocity of that car. Okay, so it have a horizontal velocity same as that of car. Okay, fine. Since the ball is thrown vertically from the car, there is no extra horizontal velocity. So the horizontal velocity of the ball is same velocity of the car, no extra velocity. Okay, fine. So when the ball is thrown vertically up from a car and the car is moving with a constant velocity, what will happen means the ball will follow a projectile motion with a horizontal velocity that is same as that of car. Okay, fine. And what will happen? The ball, after completing a projectile motion, it will come to the same place where come to the same point where car is there. That means from the same point where the not the same point, but in horizon, like see, the ball will move like this, the car will move like, okay, the ball projected, and due to it have a horizontal velocity in that of car, it will follow a projectile motion and car will move horizontally and both will reach the same point. Okay, so outside the car, no. In the car, ahead of the person, no. In the car, to the side of the person, no. Exactly in the hand which throw it up. Okay, it's a combination of our projectile motion and since there is no external force acting on the body, there is no extra velocity. So it's a combination of our two chapters. Okay, fine. A bird weighs 2 kilograms and is inside a closed cage of 1 kg. If it starts flying, then what is the weight of the bird and the cage assembled? The question is, there is a cage. There is a cage. So a bird starts flying. So what will be the weight when we measure? What will be the weight when we measure this cage and cage, like that cage with the bird flying? Okay, what is the mass of this combination? Like the bird is not sitting. It is not sitting. It is flying. Okay, even if it is flying, it will create a thrush. As per the Newton's third law of motion, law is equal and opposite relation. When it is created thrush, okay, it created thrush on air and it will impact on the cage. So net force will be the mass of the cage plus mass of the bird, that is mass of the cage plus mass of the bird, like the total, the answer is 1 kg plus 2, that is 3 kg. Okay, okay, fine. 1 second. Okay, where we are now? The bird and the cage question. Okay, one more time we can see. When the bird is flying, it pushes the air down. So this mass and mass of the cage. So 1 kg plus 2 kg. When the bird flies, it pushes the air down. Okay, so answer is 3 kg. See, a bullet of mass 5 gram moving with a velocity 100 meter per second penetrates the wooden block up to 6 meter. Then the average force imposed on the bullet on the block. Like a block is there, a bullet pierce and stop here. Okay. So by traveling 6 centimeters, after traveling 6 centimeters, the bullet stops. Okay. So what is the force imposed by the block to stop the bullet? That is our question. So we know F is equal to ma. We want to know the retarding acceleration. We want to know the retardation, that is retarding acceleration. Okay. So as we know, S is equal to ut plus half a t square, or v square is equal to u square plus 2as. In that equation, we can apply v square. V square means that the end velocity is 0. U square means since the bullet is at rest, so u is equal to 0. 2as, we can say minus 2as because of the retardation. Okay. Sorry, one second. Sorry, mistake. One mistake there. Okay. U square is equal to, sorry. V square is equal to U square plus 2as. Since acceleration is a negative one, we can say U square minus 2as. Okay. U square minus 2as. U square minus 2as. Okay. V square means the final velocity. Final velocity means the bullet stops. So V is equal to 0. Okay, sorry. V is equal to 0. U means initial velocity. The bullet moves with the velocity of 100 meters. 100 meters per second. 100 meters to A. S means into 6 centimeters. 6 into 10 raised to minus 2. Okay, 0. So A is equal to 100 square divided by 2 into 6 into 10 raised to minus 2. That is 10 raised to 4, 10 raised to minus 2, so 10 raised to 6, 10 raised to 6 divided by 12. Okay, that is our force. That is the acceleration. F is equal to ma. M is equal to 5 gram. So 5 into 10 raised to 6 into 10 raised to minus 3 gram into kilogram. Okay, by 12. That is 5,000 divided by 12. It is equal to almost, what is the answer? 417, almost 417 Newton. Okay, fine. I hope everyone understands this topic. Fine. Now let's discuss the next question. Okay, next question. A man is standing on a weighing machine placed in a lift when stationary. His weight is recorded as 40 kg. If the lift is accelerated upward with an acceleration 2 meters per second square, then the weight recorded in the machine will be. A man is standing on the weighing machine placed in a lift. The station, when stationary, the weight is recorded as 40 kg. So m is equal to 40. G is given as 10. So m is equal to 40 by 10, 4. Okay, 4 kg. So when the lift is moving above, upward with an acceleration a, we know equation F is equal to m into apparent weight is equal to m into g plus a. M for apparent weight, that weight 4 into g plus a. G is equal to 10 plus a 12. 4 into 12. 4 into 12. 48. An elevator weighing 600 kg is pulled upward with a cable with an acceleration 5 meters per second square. G to be 10 meters per second square. The tension in the cable. Okay. An elevator weighing 6,000 kg. Okay. Pulled upward by a cable with an acceleration 5 meters square. 5 meters per second square acceleration upward. G is equal to 10. The tension. Tension is equal to same. Tension is same as that of apparent weight. M is equal to G. M into G plus A. M is 6,000. G plus A. G plus A. G plus A. G 10 plus A acceleration 5. 6,000 into 15. 90,000. This is same as that of apparent weight. Okay. Like here, instead of measuring weight, we are seeing the tension. Okay. Same. Simple. So next question. n bullets, each of mass n kg, small m kg, are fired with the velocity v at a rate of n bullets per second on a wall. The reaction offered by the wall to the bullets is given by. So total mass is equal to if n bullets are of mass small m is fired, total mass is equal to n into small m. Okay, now. So the velocity is v at a rate of n bullets per second. So the time we can calculate is equal to n by small n. Okay, fine. N by small n. Like n bullets per second. In 1 second, there is n bullets. So time is equal to n by capital N. Okay. So acceleration is equal to Vt. Acceleration is equal to Vt. So acceleration is equal to Vt. That is n into n by n into v. Okay. F is equal to ma. That is n m v. Sorry. NMA, 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 NM. Sorry. Once more. That mass is actually mass is equal to see once more. Total mass is equal to nm. Total mass is equal to nm, and time is equal to n by n. Okay, and acceleration is equal to vn. Okay, vt. So the force is equal to n m v divided by n. So let's see the next question. This is the question actually I told you that where there's a mass, we can see a change in mass. Okay. See, a rocket of mass 10,000, so 1000 kg exhaust at the rate of 4 kg per second. That is dm by dt is 4 kg per second with the velocity of 3000 meter per second. The thrust developed, that is F is equal to since the F is equal to, here we can apply v dm by dt, v dm by dt, v dm by dt. That is v is equal to 3000 into dm by dt is 4, that is 12,000. Fine. So next question, a block of mass m A block of mass m is pulled with a block of mass m is pulled with along a horizontal frictionless surface by a rope of small m. Okay, by a rope of small m. If a force P is applied at the free end of the rope, the force exerted by the rope on the block will be. Okay, let's see how we can solve this question. Okay, like there is a mass, there's a mass, and it is pulled with another mass and by a rope. That rope is also a mass. Okay, this is capital M and this is small m with a force F. Okay, force P. Okay, force P. So there's a mistake in this question. Okay. Sorry, it's my mistake. Here the question is having a small thing we should see actually. Okay, let's see. Once more. M is equal to total mass is equal to n into small n. Okay, fine. Time is equal to n by n. That is okay, fine. And momentum is actually mv. Okay, mv. And F is equal to change in momentum by time. So n m v divided by t. That is n m v divided by t is equal to n by n, capital N by into small n. nmv. Sorry, this is my mistake. Okay, fine. Now it's okay, fine. So okay, now come to here. This question first. A force is applied on P. So total acceleration. Acceleration I already told in this here. F is like acceleration is equal to. So here acceleration is equal to F by m. Here acceleration is equal to F divided by m1 plus m2. So like this. Here acceleration is equal to P divided by m plus small m. Okay, m plus small m. Okay. So this is the force on capital M is m a. So F is equal to m a. That is m p divided by m plus small m. This is answer. Fine. So a block of m1 rests on a horizontal table. A string tied on the block is passed on a frictionless pulley fixed at the end of the table, and the other end of a string is hung by another mass of m2. The acceleration of the system is. See, this is the thing. m1 mass, a pulley. m2 mass. So acceleration of the system is the question. I already told acceleration is total force by total mass. Okay, that is simple. Total force by total mass. Total force is m2 doesn't create any force because of m1. So m1 doesn't have any force because m1g is there, but then it doesn't have like m1g is there, but normal reaction m1g is above, so it is cancel each other. So no net force is external force is created because of m1, but because of m2 there is m2g is created, external force is created. Okay, so m2g is our is the force, total force m2g, total acceleration by total mass, force by total mass, total force divided by total mass m1 plus m2. So this is a question where we have I have also a confusion. So this we solve now. So this type of tricky questions can become okay. Fine. This was a combination of momentum, second law of Newton's second law of motion, everything. Okay. So we have discussed almost the types of the question, and the remaining part of this thing will be discussed today. There is some topics which I want to cover, and I will cover tomorrow. Okay, fine. So we covered almost the part 1 and some topics of part 1, and the remaining of part 2 we will be covered tomorrow. Okay, fine. We covered inertia, Newton's first law of motion, momentum, Newton's second law, impulse, third law, and law of conservation. And we have discussed some of the cases and some of the questions. Tomorrow we'll discuss friction and the remaining questions of part 1. Okay, fine.